right, so the warm-up for 5-3 covers your solving of your trig equations. Okay, the directions this time said find them on the interval of 0 to 2 pi, and that should have a bracket on the 0 and a parentheses on the 2 pi, okay? Which means I'm going to start at 0 and go to 2 pi, but I don't need to include 2 pi because I've already included it by using 0. So I'm looking for angles that are all the way around my unit circle for answers here, and I don't have to add on that 2n pi or the n pi for tangent. So I'm going to come back to example 1, or number 1, when we go through the multiple angle equations, but let's start with 2. So 2 says secant squared x minus secant equals 2. Hopefully you thought about the fact that you need to factor this, right? So I have to get everything to one side. So I'd get secant squared x minus secant x minus 2 equals 0. And then I have to factor that. So I'd get secant x and secant x. And then factors of -2 that would sum to -1 would be -2 and +1. And then I'm going to set each of those parentheses equal to 0, and I'd get secant of x equals 2, and secant of x equals -1. But secant's not on my unit circle, so what do I do? Flip it and make it cosine, right? So this becomes cosine of x equals 1/2, and cosine of x equals -1. Then I go to my unit circle and I want to find everywhere the cosine, which is my x coordinate, is positive 1/2 or -1. So it would be here, it would be here for the positive 1/2, and then it would be here for the -1. So my answers are just going to be pi over 3, pi, and 5 pi over 3. If it did not restrict the interval, then to each of those I'd be adding 2k pi or 2n pi. Same thing. Questions on that one? Okay, then number 3 says 2 secant squared plus tangent squared minus 3 equals 0. I cannot solve an equation with it's like having 2 different variables, right? I can't have 2 different trig functions. So you want to look at these and you want to replace one with the other if you can. What's the relationship between secant squared and tangent squared? Do you remember the 1 plus tangent squared equals secant squared, right? That's one of your Pythagorean identities. So you could choose which one you want to replace, and it doesn't really matter. My advice would probably be to replace the secant with the tangent because you already know the tangent values, and then you wouldn't have to flip it to get the cosine. But honestly, it's not that much of a difference. So if I know that secant squared equals 1 plus tangent squared, then I'm going to say 2 times 1 plus tangent squared x plus tangent squared x minus 3 equals 0. Then I'm going to distribute the 2, so I get 2 plus 2 tangent squared x plus tangent squared x minus 3 equals 0. Combine my like terms, and I get 3 tangent squared x minus 1 equals 0. 3 tangent squared x equals 1, tangent squared x equals 1/3, and then plus and minus the square root of that is plus and minus 1 over root 3, which rationalizes to root 3 over 3. With me so far? So now I'm going back. Yeah, you just didn't have to flip it at the end. Yeah, I said it doesn't matter which one you pick. Yeah, it's just, yeah. All right, so now I'm going back to my unit circle, and I'm looking for where tangent is root 3 over 3, okay? So I'm going to give you, again, blank unit circle day before the test. You fill in as much of it as you can, and then you'll get it back. I'm not going to grade it that time, so you want to make sure that whatever's in your brain is right, okay? But to save time from the actual day doing it, we're going to do it the day before. What that means is by then, hopefully, you should have added on the tangents at over 6's are your root 3's over 3's. You don't necessarily have to fill out the entire thing. You don't have to fill out every quadrant, but maybe a note like that is fine. You can add on your tangents, okay? Which means that every over 6 is going to be my answer because it's positive or negative root 3 over 3. So I'm going to have pi over 6. I'm going to have 5 pi over 6. I'm going to have 7 pi over 6 and 11 pi over 6 are all included in your answers. Questions on that one? All right, questions from homework? All right, so as soon as I see that there's a sine and a cosine, I know I have to change something, right? You can't have two different variables. So because I can't do anything with cosine to the first, I'm looking at sine to the second. So how do I rewrite sine to the second so that it's in terms of cosine? So that's where you would say, okay, if sine squared plus cosine squared equals 1, then sine squared is the same thing as 1 minus cosine squared. And then I take this and plug it in there. So 24 times 1 minus cosine squared x equals 24 minus 12 cosine x. Then distribute your 24. So 24 minus 24 cosine squared x equals 24 minus 12 cosine x. Now I got a cosine squared and a cosine. So this is like having an x squared and an x. I'm going to have to get everything to one side and factor it. So because I want my square to be positive, I'm going to move this stuff to the right. So I'm going to subtract the 24 from both sides. I'm going to add the 24 cosine squared to the right side. And I have 0 equals positive 24 cosine squared x. The 24s are going to cancel. Minus 12 cosine x. Now I can factor out a 12 and a cosine. So 0 equals 12 cosine x. And I get 2 cosine x minus 1. Then I set each of those equal to 0. So for the left-hand side, I would divide both sides by 12. And I'm looking for where cosine is 0. The right-hand side, 2 cosine x would equal 1. Cosine of x would equal 1/2. And then go to your unit circle. Find where the x is 0, which is at pi over 2, and 3 pi over 2. Go where the cosine is positive 1/2, which is at pi over 3, and 7 pi over 3. No, sorry, 5 pi over 3. Did it restrict your interval, or did it say just solve it?
No, it just said solve it.
So each of these, on the homework they used n, so each of these would get 2n pi. Jasmine.
How did you get the 2 cosine x minus 1?
This one?
Yeah.
So from here, they both, like the greatest common factor would be 12 cosine. So I took out the 12 cosine, divide this one by 12 cosine, and I get 2 cosine. Divide this by 12 cosine, and I get 1. Equals 0? So I get 3 cotangent squared of x equals 1. Cotangent squared of x equals 1/3. Cotangent of x equals plus or minus the square root of 1/3, which means tangent, right, would equal plus and minus the square root of 3 over 1. So you're looking for everywhere square root 3 is, right, which is all the over 3's on your tangent. Because it's tangent, it happens every half circle, right? So you could do pi over 3 plus n pi, and then the next one would be 2 pi over 3 plus n pi. So you got the pi over 3 one? Yeah. Just because it's plus and minus, it's got to be both. And with tangent, you don't need all 4 because every half one, like if I say it's here, and then I am adding pi, it's here, and then it duplicates back around. Where sine and cosine, it happens every 2 pi, so you'd have to include what's on there. So if this was like a test question, and it's open-ended, which these probably will be, and you gave me all the over 3's, I'm not going to mark it wrong. Like you're giving me more than I need, but it's not wrong. Does that make sense? Because it happens every n pi, if I did pi over 3, that means it's also happening at 4 pi over 3, which would be the other spot. Any other questions from the homework?
Number 6.
What'd you say?
Cosine x times cosine x minus 1 equals 0.
Okay, so it's like already factored for you, right? So you got to split it up. So I'd get cosine of x equals 0 and cosine of x minus 1 equals 0. So I'm looking for where cosine or the x is 0 and where cosine of x equals 1. So on your unit circle, cosine is 0 at two places, pi over 2 at the top and pi over 3 at the bottom. Pi over 2 and 3 pi over 2. And then the cosine is positive 1 at 0. Did it give you an interval?
No, but I see what I did wrong.
Okay, so to each of these you would add 2 and pi.
For that one, for the second value, I put 3 pi over 2 plus 2 n pi, and it said it was 1.
All right, is it in that order?
Like, that was the larger one.
Technically, oh yeah. It gave you 3 spots?
Give me 2.
Because it should be and 2n pi technically, right? You don't need the 0. 2n pi, which would be the biggest one. And then pi over 2 would be the smallest, and 3 pi over 2 should be the middle. I'll look back at that one. That's fine.
It said 0 was the smallest for me.
So if n equals 0, then none of these intervals work. It's restricting your interval,
So you're not supposed to write it?
so you don't need it.
But
If it's telling you that that's what it said, n equals 0, then it eliminates all your intervals. It's like restricting it.
for the first one, it said 0 plus 2 n pi was great for the smallest one.
Let me look at it again. So so the answer would have been, like if you're just listing them, it would have been 0, right, plus 2n pi, pi over 2 plus 2n pi, and 3 pi over 2 plus 2n pi. But it asked, like, if it was in order, where would it be, right? Is that what it was?
It was, yeah. Like it just says solve for equation x uses.
So if you were going to give me a list, like I think the wording on it is a little confusing. If you're going to give me a list and I didn't give you the interval, then I would have taken all 3 of those, not with the cross throughs. I would have done 0 plus 2n pi, pi over 2 plus 2n pi, and 3 pi over 2 plus 2n pi. They only gave you 2 answer choices, right?
Yeah.
Which the first one, it was saying if n is 0, what's the smallest, which is that, right? 0 plus 2n pi would be the smallest. So that's what would come first. And then it only gave you one other option, right? So the unique thing about cosine is that when it's 0, it's here and here. So it takes on the characteristic of tangent where it happens every half circle. So instead of writing pi over 2 plus 2n pi and 3 pi over 2 plus 2n pi, you could have written pi over 2 plus n pi. And it would have done the same thing, right? Then you would have had 3 pi over 2. Then you would have had 5 pi over 2. It would have gone all the way around. But test-wise, if you list them all, like what's the first thing? That's, yeah.
Because I got the answers, but I didn't know how to answer the question.
Yeah. You're welcome. The last thing from 5.3 is called multiple angle equations, okay, which this example 4. And sometimes the instructions say solve the multiple angle formula, and so it's telling you you're doing this different, but sometimes they're going to get looped in just like on the warm-up where it just said solve, and you have to be able to look at the equation and identify something's different with this one. The method I do is different. The way you do that is look at your x. If there's anything attached to your x, then it's a multiple angle minus the squared, right? The squared we already did, we would square root both sides. But notice that here this is a 4x. Normally that just says x there. But now we're changing it because it says 4x. And this is x divided by 3. Normally that's just an x, but now we're saying divided by 3. So the way you do these are called multiple angle equations. The way you do these is a little bit different, okay? So the first thing I would do is solve for the trig function, which this is already done for you. If it said something like sine of 4x minus 1 equals 0, then my first step would have been to add the 1 to the other side. But this is already solved like that for you, okay? So now I'm not saying 4 times the sine of x equals 1. I'm saying the sine of an angle equals 1. Tell me that angle, right? So the first thing you do is figure out where sine is 1. So think about your unit circle. Where's your y? 1. Pi over 2. And normally it's just x equals pi over 2, you're done. But it's not x, it's 4x, which means I have to say 4x equals pi over 2. And now I have an additional step after I locate the angle. I got to get x by itself. So in this case, I'd be dividing by 4 or multiplying by a fourth, and I get x equals pi over 8. So hopefully that's not the hard part. Nope. Because now you got to think about how this impacts your interval, right? So there's 2 different approaches depending on the instructions. If the instructions said on the interval of 0 to 2 pi, well, let me go the way that it is now first. It doesn't have my interval, right? So if it doesn't have an interval, what do I normally do to the angle? If it's sine. Add 2k pi or 2n pi, right? So go back to before we divided by 4, because that's when I would want to do it. So it is pi over 2 plus 2, I'm going to do n because your book does n, but 2n pi. K pi, n pi, same thing.
But why the pi over 2?
Because you're looking for where sine is 1. So you're ignoring the 4x first. And you're looking for what trig function, or where the trig function, in this case sine, is 1, which is at pi over 2. But instead of it just being x equals pi over 2 plus 2n pi, it's 4x equals pi over 2 plus 2n pi. So now I got to divide the entire thing by 4, which means the x obviously becomes, or 4x over x becomes, 4x over 4 becomes x. And then I multiply both of these by 1/4, and I get pi over 8 plus 2n pi over 4, or n pi over 2.
So you have to always have in that second part, and you have to divide that as well.
Yep. So hopefully that's not too bad, because what comes next is what's not fun. It's not bad, but it's not fun. So this would be as though the question did not restrict your interval. Everybody good so far? Now let's say that it does restrict your interval. Usually it's easier, right? On the other problems, it actually makes it easier, not with multiple angles, okay? Because if it said from the beginning on the domain of 0 to 2 pi, then I would do exactly what I just did. So if it said 0 to 2 pi, I would start exactly the same way as you did. Take the angle, add on the 2n pi, divide it by 4, and then I get to pi over 8 plus n pi over 2. But what I have to do with this is if it restricts the domain, is actually make n1, make n2, make n3, 4 until I get to the point that it is bigger than 2 pi. Because it's not your standard angles anymore, right? It's pi over 8 plus a half pi. So I'm going to take pi over 8, which is going to be the first answer I would have, and I'm going to add on as though n were 1, so pi over 2. This would be 4 pi over 8, and I get 5 pi over 8. Is 5 pi over 8 on my standard unit circle? Is it bigger than 2 pi? No, so I have to include that one. Then I'm going to do it again, plus 4 pi over 8. And I get 9 pi over 8. Is that bigger than 2 pi? Nope, so I got to keep going. So then I'm going to add 4 pi over 8, and I get 13 pi over 8. Still not bigger than 2 pi. Got to keep going. 4 pi over 8. 17 pi over 8. That's bigger than 2 pi. Yeah? So I know I'm done. The last one doesn't count. But all these other angles would be a part of my domain. So pi over 8. 5 pi over 8. 9 pi over 8. 13 pi over 8. All 4 of those are within that range. So again, if it doesn't give you the interval, then you just want to make the same adjustment to your 2n pi that you do to your angle. If it does give you the interval, then you have to treat n as 1, n as 2, n as 3. Keep going until that number has become bigger than 2 pi. Yep.
I have 2 questions. The first one is like, so when you're answering it with the interval, you don't answer it with the, like how you did in the first part, which is...
This would be the answer if it didn't have an interval. This would be the answer if it did.
And then the reason you have to add on is because since we changed the interval...
Right, we're actually normally we say it's plus 2n pi. So as soon as I do the first one, it's going to be over 2 pi. But now we're saying it's not every 2n pi for this specific one. It's for every half pi. So it's going to happen more. Yeah, exactly.
So it's not like that you like change n
It would be the same effect.
Oh.
For me, it's just easier to keep adding the same number over and over again than it is to change n, but it would be the exact same thing.
It's like you just always, like, whatever you add first.
You just keep adding until it's too big. Yep.
So if you have an interval and you don't have an interval, you're still going to be using the...
You still start the same way. So you still do the angle plus the interval because you have to have that interval impacted the same way as the angle. So if that was 10x equals whatever the angle is, I have to divide both the angle by 10 and the interval. So you add on the interval plus 2. If it's sine or cosine, 2n pi. If it's tangent, n pi. Then do whatever you got to do to the x to get it by itself. That's going to impact the angle and the interval. If it didn't say from 0 to 2 pi, you're done. That's your answer. If it does say from 0 to 2 pi, then you have to use that first angle and then add that interval until it gets bigger than 2 pi. Does that make sense? Okay, so let's look at B. B says tangent of x over 3 equals 1. Again, if there was something like in front of the in front of the tangent, I would divide by it first, but this one's already solved. So the first question is, where is tangent 1? So on your circle, where does it happen? Pi over 4 and 5 pi over 4. With tangent, we do what to that?
It's plus pi.
Plus n pi. So what's true about those two angles? What happens if I do pi over 4 plus n pi? It is 5 pi over 4. Does that make sense?
Yeah.
That's when you don't need the duplicate. So you could continue and go on, and if you're just going to get duplicate angles, but if you could see it, ignore it. Because by doing pi over 4 plus n pi, you're going to take care of the other one.
You put the other one as an extra when you mark it wrong?
No.
All right.
No. If you duplicate them, I'm not going to mark them wrong. Okay, but x over 3 equals this, right? Not just x. So then to both of these, I'm going to multiply everything by 3. I get x equals 3 pi over 4. 3 pi over 4 plus 3n pi. I have to multiply everything by 3. So if it doesn't ask me for an interval, I'm done. If it does say from 0 to 2 pi, then the first angle is going to be 3 pi over 4. What happens when I add 3 pi to this? Is it going to be bigger than 2 pi? Yeah, so I totally ignore it, and that's the only answer that would have worked. So this would be without the interval. This would be with the interval. If you had kept 5 pi over 4, like let's say like that happened, right? And I had kept it, I would have gotten x over 3 equals. I would have gotten x equals 5 times 3, which is 15 pi over 4. Plus 3n pi. If my interval is restricted from 0 to 2 pi, what's wrong with 15 pi over 4? It's already too big just by itself. That's why you would rule it out. Does that make sense? Okay.
How do you add the 3 pi? Like, where do you get the 3 pi from?
The 3n pi or the 3 pi?
The 3.
So,
Oh,
exactly. You start with n being 1.
Oh, so for when it's with the interval, you just add whatever you would have been adding.
Exactly.
Oh.
You start with n being 1 and then just keep adding it until it's bigger than 2 pi.
So for the first one, it's just pi over 2? Because,
Correct.
Oh, okay, that's it. Because I didn't know where you pulled the 4 pi.
Yeah. So the good thing with these is with added time, just like all the equations, you can check every single one of these answers. If I take pi over 8 and I plug it back in, let's just say I check this one, right? I would get the sine of 4 times pi over 8 equals 1. And then the sine of 4 pi over 8 becomes pi over 2. And the sine of pi over 2 is 1. So my answer works, right? So the good thing about all of these is that these are checkable. The bad part is the time it takes you to do it, right?
I don't understand how, if you add 2 pi over 4 to 3 pi over 4, you just get 5 pi.
If you add
So
2...
it's like a how. You know how you get 3 pi over 4?
Yeah.
So would you add 2 pi over 4 to that?
But you mean in general, or you mean if it's a multiple angle one?
In a multiple angle.
Because it's not, so n pi, you had to multiply, normally you would add n pi, right?
Yeah.
But you're multiplying by 3. So instead of adding n pi, you're adding 3n pi.
So you would be technically adding 3n pi.
Yep.
But then that would give you.
And then if you're restricted on the interval, if you add 3 pi, it's too big, so you don't use it. All right, so I'm going back to it because this is, if you notice, like, now you see it says 3x, that's how you know it's a multiple angle one, right? The directions this time just said solve. It didn't give you any indication that it was a multiple angle one. You've got to be able to look at them and identify that it's different. So the fact that it says 3x on the left means that this is actually a multiple angle one. This is not. It doesn't matter for the tangent of -1. So I get tangent of 3x would equal 0, and then tangent of x minus 1 equals 0, which means tangent of x equals 1. So let's solve the right side because that's the easy one, right? Where is tangent 1? On the interval of 0 to 2 pi. So picture your unit circle in your brain. Go all the way around your unit circle and tell me wherever you would see tangent being positive 1. Pi over 4? 5 pi over 4. 2 places, right? That's it. So those are good. That would be a super easy, nice question. Now I look at the left. Now it says tangent of 3x equals 0. So I want to figure out where on my unit circle tangent would be 0. So think about where that happens. Where's tangent 0? At 0 and at pi, right? But I don't need pi because tangent's every half. So I would say that 3x equals 0 plus n pi, because that's what we would add on to the interval for tangent. You with me so far? So then to both sides, I'm going to divide 3. And I get x equals 0 plus n pi over 3. And because it's a restricted domain, I'm going to include 0. So that's my first angle. But then I got to see, would there be more if I change n to 1 and then keep adding it, right? So from 0 plus pi over 3, I'd get pi over 3, which is smaller than 2 pi, so I'm going to keep that as an answer. Add pi over 3 again. 2 pi over 3, that's smaller than 2 pi, so that's an answer. Plus n pi over 3, or sorry, 2 pi over 3, which is 3 pi over 3, or pi, smaller, plus pi over 3, 4 pi over 3, that's an answer, plus pi over 3, 5 pi over 3, that's an answer.
So you
And then,
add by the n, like you're adding by pi over 3
because you want to make n 1, that's the first thing you're going to add, and then you just keep adding it until it gets bigger than 2 pi, so, or equal to or bigger than 2 pi. So if I add pi over 3 again, I get 6 pi over 3, which is 2 pi, and that's too big because my parentheses is on the 2 pi. So all of these answers, pi over 3, 2 pi over 3, pi, 4 pi over 3, and 5 pi over 3, would have to get added on to my list. Questions on that? Yep. Yeah, because 0, the first one would have been 0, right? And then it happens every pi over. So you still want to include this one. Like 0 is your first one. And then you want to add as though n was 1 and n is 2 and like that.
For the multiple angle one, the one that has a 3, why didn't you also do it for pi?
Because tangent is plus n pi, right? So I'm already adding to get to pi.
So you just ignore it?
Yeah. So tangent, you really only need the first one of each value, right?
Okay.
If there's 2 positives, you grab the first one because then you add n pi, that would hit the second one. Tangent, sine and cosine, we add 2 pi, so you bypass the second one. But tangent, you add n pi, so it accounts for it. You would have multiple answers. You'd have duplicates of answers, and you'd notice it. Okay, so. All right, so the first one I said solve on an interval of 0 to 2 pi if 2 sine of 6x equals negative root 3. So the first thing you have to do is divide both sides by 2. And I get sine of 6x equals negative root 3 over 2. So now I'm looking on my unit circle, where is sine negative root 3 over 2? And it happens 2 places. I'm looking on the whole unit circle. So it happens 2 places, which is at 4 pi over 3 and 5 pi over 3. And then this is sine, which means I add onto this 2 and pi in both spots. If it wasn't a multiple angle, that's where you'd be done, right? But this is here, so I have to say 6x equals that. And then I would divide both sides by 6 or multiply everything by 1/6. And I get x equals 4 pi over 3 over 18, which is 2 pi over 9. Plus 2n pi divided by 6, or n pi over 3. And then on the right, x would equal, same thing, 5 pi over 3 times 1/6, 5 pi over 18, plus 2n pi divided by 6, which is n pi over 3. With me so far? So if it didn't say an interval, you'd be done. You pray for one of those questions, right? If it does say an interval, which it does, then I actually have to work this out as though n were 1 and 2 and 3 and 4 in both spots until I've exceeded my 2 pi. So if I take 2 pi over 9 and I add to it 1/3 pi, or pi over 3, that becomes 3 pi over 9, and I get 5 pi over 9, which is still on my unit circle, so it's got to be part of my answers. I would add 3 pi over 9 again, and I get 8 pi over 9, still on my unit circle. Add 3 pi over 9 again, I get 11 pi over 9, still on my unit circle. 3 again, 14 pi over 9, still on my circle. 3 again, 17 pi over 9, still on my unit circle. Add it again, I get 20, God bless you, 20 pi over 9, that's when it's too big. So for the first angle, it's all of those. And then I got to do the same thing for 5 pi over 18. I would start with 5 pi over 18. I would add to it n pi over 3, or pi over 3. The denominator this time has to be 18, so this would be 6 pi over 18, and I get 11 pi over 18. That one works. Add 6 pi over 18 again, 17 pi over 18. That works. Add 6 pi again, 23 pi over 18. Still less than 2 pi. 6 again, 29 pi over 18. Still less. And then add 6 again, 35 pi over 18. If I add it again, I get 41 pi over 18. That's too big. So for those, I would start at 5 pi over 18, and then all of these, this one, and all of these. Questions on the process? Okay, the next one, a little bit easier because now we don't have that interval. So where is cosine negative 1? It only happens one place, it's at pi. So I would get that 8x equals pi plus 2n pi. Divide everything by 8. And I get x equals pi over 8 plus n pi over 4. This last one just says solve tangent of x over 9 equals 1. So because the interval is not mentioned, I know that I just need to solve it, add the interval on, adjust the interval, but then leave it alone. So because it already has the trig function isolated, I don't have to move anything yet. What I'm looking for is where tangent is 1 on my unit circle, which is going to occur both the first quadrant and the third quadrant. But because we add n pi onto tangent, we don't need the third quadrant. We just need to include pi over 4 plus n pi. So if I add a pi on, I'm going to get here, here, and so on and so forth. But instead of that just being x, now it says x over 9 equals pi over 4 plus n pi. And to isolate the x, I'm going to multiply everything by 9. So x equals 9 pi over 4 plus 9n pi. And that's your answer. If this had given the interval of 0 to 2 pi, this is one of those cases where if I made that 1, I'd be adding 9 pi, which is bigger than 2 pi. So the only answer would be that 9 pi over 4.